to teach you how to solve maximization LPP problem under simplex method. So we will go to the sum straight away. We'll take the sum. So the first one is solve by simplex method. The models given below. The first one, we will solve it. So what have they given? Max Z is equal to 22x1 plus 18x2, subject to x1 plus x2 less than or equal to 20, 360x1 plus 240x2 less than or equal to 5760, where x1 and x2 greater than or equal to 0. So your first step when you solve maximization LPP under simplex method is you have to check what is your objective. The objective is maximization. So if the objective is maximization, you have to see at least one constraint is in tune with the objective function. If the objective is maximization, at least one constraint should have less than or equal to sign. So in the given problem, both the constraints, you find that they have less than or equal to sign. Supposing if the sign was greater than or equal to, what you need to do is you have to multiply the entire constraint by -1. So all the signs will change, even the inequality sign will change. So in this case, the first step is what? We have to check whether the constraints are in tune with the objective function. So here the constraints are in tune with the objective function. So first step is done. So second step is you have to introduce appropriate variables and modify this particular model. So we are going to modify this model. How do we modify? I'll write here revised objective function. Revised objective function. Now, revised objective function, I'll write here max Z is equal to 22x1 plus 18x2, and then whatever variables that you are introducing, those variables we have to include it here. Subject to, what is the first constraint? It is x1 plus x2. Here you have less than or equal to sign. So whenever you have less than or equal to sign, something has to be added here, and this x3 will be a slack variable because it is less than. It can be less than or it can be equal to. Supposing if the left hand side is less, so something has to be added to make it equal to 20. Therefore, x3 is added here. Why are we adding a slack variable? I'll write here because of less than or equal to sign, and x3 is a slack variable in this particular constraint. Okay, now first constraint is over. Now the second constraint also has less than or equal to sign. So I'll write 360x1 plus 240x2. Now again, this is less than or equal to. So something has to be added here in case if it is less than. So something has to be added on the left hand side to make it equal to 5760. So whenever you have a less than or equal to sign, you need to introduce a slack variables in the model. So I'll write here x4 is a slack variable. X4 is a slack variable where x1, x2, x3 and x4 greater than or equal to 0. Greater than or equal to 0. Now you have to modify the objective function because you have introduced two slack variables, and slack variables will generate zero profits. They will not earn any profits. They are unused resources. Therefore, 0x3 plus 0x4. So always remember, whenever you introduce a slack variable in the constraints, so in the objective function, the coefficient of slack variables will be 0. So this is the second step. First one, we check whether the constraints are in tune with the objective function. At least one constraint should be in tune with the objective function. If it is a maximization problem, at least one constraint should have less than or equal to sign. Now, after you write this step, now the second step is to prepare the initial simplex table. So this is the initial simplex table. So in the initial simplex table, what we do is from the constraints or from the model that you have constructed, you take the slack variables. Remember, we don't start with the basic variables. Basic variables are the ones which are given in the question, that is x1 and x2. Now, we don't begin the problem with the basic variables. We always start with the variables that we have introduced. In this case, for the in the first constraint, the variable that is introduced is x3, and in the second constraint, it is x4. So these are the two variables we will begin with. So under initial simplex table, program variables, I will take it as x3 and x4. So these are the program variables. And then you have to see what is a profit. If it is a maximization problem, here you will have profit. If it is a minimization problem, then you will have to write cost. Now, in this case, it is a maximization problem. So I've written profit, and you will take from the objective function, that is the revised objective function, what is the coefficient, because this is the profit. So if you produce x3, profit earned is 0. If you produce x4, profit earned is 0. So in this table, you will write 0 and 0. Now, what is quantity? Quantity is the right-hand side value of your constraint. So in the first one, it is 20, and the second one, it is 5,760. So we fill in the right-hand side value of your constraints. So first one constraint is 20, and the second constraint's right-hand side value is 5,760. Now, how do you fill up these columns? Okay, so the first one is, you see the first constraint. In the first constraint, I know the coefficient of x1 is 1. Why? X1 means it is 1x1. Similarly, when I say x2, it means 1x2. So when there is no number here, by default, it is 1. So it is 1x1, 1x2 plus 1x3. Therefore, for x1 coefficient is 1, x2 coefficient is 1, x3 coefficient 1 is 1. There is no x4 in the first constraint. Therefore, I'll write 0. Now, moving on to the second constraint, the coefficient of x1 is 360, x2 is 240, no x3, and then x4. So it is 360. And the second constraint coefficient is 240. There is no x3, but you have x4, that is 1. Now, the constraint, you have to take it from the what is z value? They are the coefficient from the objective function, max z. What is the coefficient? x1, it is 22. x2, it is 18. x3, it is 0. And x4 also 0. So we write here, it is 22, 18, 0, and 0. So what is z value? Z values are the coefficients from the objective function. Now, coming to the next one. So at this point, you can make one small check whether you made any error. You have taken x3 and x4. So if you see the columns x3 and x4, the coefficients of this should form a unit matrix. That is 1, 0, 0, 1. It should form a unit matrix. So the program variables x3 and x4, when you take it here, it should form a unit matrix. Okay, now how do I compute C? Now, what is C? Computed value. You multiply the profit. This is the profit, this column. You have to multiply with this particular variables to get this value. So I mean, it is 0 into 1 plus 0 into 130. I repeat, 0 into 1 plus 0 into 130. So how do I get that? It's 1 into 0 plus 360 into 0. I'll get 0. Now, if I want to find out what is this value, so what I will do, again, this column, whatever the numbers you have, so it'll be 1 into 0 plus 240 into 0. So you will get 0 because 0 into 1 is 0. 0 into 240 is also 0. So 0 plus 0 will be 0. In the first one, it is 0, 0, 0. Similarly here and here. And what is NER? NER is Z minus C. So the objective function variable, whatever you have got, minus the what you have computed, that is C. These two, if you minus it, whatever value you get, we call it as net evaluation, NER, net evaluation row. So this is equal to 22 minus 0, 18 minus 0, 0 minus 0, and 0 minus 0. So the first one is 22 minus 0, 18 minus 0, and 0 minus 0. So this is what is the NER. Now, after you compute NER, okay, for a maximization problem, you have to see what is the highest positive number. So what is the highest positive number? It is 22. 22 is the highest positive number. This particular column will be taken as the key column. So this will be called as the key column. Because why did you select this? Because 22 is the highest value. This will be taken as the key column. Now we have to identify. So once you identify the key column, the variable what you have here, that is x1, this will come in the table. That means you have to produce x1. Now, when you produce x1, so in the next table, x1 will come in. And in which one should go out? There are two variables, x3 and x4. So should you stop producing x3 or should you stop producing x4? How do you determine that? You have to find out what is RR. How do you find RR? RR is equal to quantity divided by the key column element. Quantity divided by the key column element. So how did I get this 20? How did I get 20? It is the quantity divided by the key column element. Quantity divided by key column element. So 20 divided by 1. And then 5,760 divided by 360 will give you the other. Now in this, you have to see which is the lower value. Do you understand? So you have to see the least non-negative number. So in this case, the least non-negative number is 16. So this will be taken as the key row. This is the key row, and we will put this in one box. So we have to identify the key column and the key row. And the intersection of the key row and the key column, we have to select this and we have to call this as the pivot element. We will write it as PE, pivot element. So key row, how do you select? You will select the least non-negative number. Supposing if there is 0, you will select 0. If there is a tie, you will make arbitrary selection. Okay, so this is the second row is the key row. The intersection of the key column and the key row, we will call it as the pivot element. So what does this key row say? So since you have to produce x1, something has to go out from the table. So x4 will go out. So x4 will leave the table and x1 will come in its place. And for the key row, there is no fixed ratio. We will take it as NA, not applicable. Always for the key row, a fixed ratio, you need not compute. Fixed ratio is not applicable. For the non-key row, we have to find out the fixed ratio. How do you calculate the fixed ratio? It is the key row element, key column element divided by the pivot element. So how did I get this value? It is the key column element divided by the pivot element. So in this case, the key column element is 1 and the pivot element is 360. Now in the table, always keep it in fractions. Do not make it into convert it into decimals. So now when you prepare the second simplex table, remember the order of the program variables you're not supposed to change. So first is X3 and then X4, but X4 should leave the table and X1 should come in its place. So we know that the incoming variable is X1 and X4 should leave the table. So when you prepare the second table, you'll write X3, X1. Now, again, the same procedure. Go to the model and see what is the profit. X3, it is a slack variable, so profit is 0. Whereas X1, the profit from the objective function is 22. So you will write here 22. You will write here 22. So this is the profit. Now, how do I fill up the first one? You fill up the key row. The second row is the key row. For the key row, how do you compute the value? It is the previous in the table, previous table, whatever the element, that divided by the pivot element. Pivot element is 16. So I repeat, for the key row, how do you compute the values? It is the existing element divided by the pivot element. Existing element divided by the pivot element. Go to the previous table, see what is the value there, that divided by the pivot element. So it is 5,760 divided by 360. So how do you get this? It is 5,760 over 360. Similarly, 360 divided by 360 and then 240 divided by 360 and so on, you get these values. Now, how do I compute for the non-key row? So the second row is the key row. How do you calculate the non-key row? For the non-key row, what you should do, go to the previous table, take the existing value, minus, open the bracket, you see what is the key row element into the fixed ratio. Fixed ratio is 1 over 360. You have to minus it. So I repeat again, how did I get this value 4? How did I get this? You go to the previous table existing value is 20. So 20 minus, open the bracket. You see what is the key row element? It is 5,760. This into the fixed ratio of that particular row, that is 1 over 360. So when you do this, you get this value. And this has to be done for all the other things also. So how do I do the next one? It is 1 minus, open the bracket. It is the key row element into fixed ratio, which is 1 over 360 and close the bracket. This is what you need to do for all the other elements. So we have computed the first row as well as the second row. Objective function column will not change. This column will be the same because these are the values from the objective function, coefficient of the objective function that is constant. Now we have to compute what is C value. How do you compute the C value? Like what you did in the previous table. It is the profit into the numbers that you have. So this is the profit and these are the numbers. So it will be 0 into 0 plus 22 into 1. So how do I compute this? It is 0 into 0 plus. It is 1 into 22. I'll get the value, computed value is 22. Similarly, you compute it for the others. I get these values. And now you have to find out what is Z minus C. Z minus C will give you NER. So calculate for everything. So I got these values. Now, again, we have to check whether you have any positive numbers. So you have one positive number. You have to take the one which is the highest positive number. I find that this is 0, this is 0, and this is minus. So this is the number which is the highest positive number. So this will be selected as the key column. So key column is, this is the key column. So you have to put this in one box. You have to identify this key column in your table. Now you have to find out what is the replacement ratio. How do you calculate the replacement ratio? It is the quantity divided by the key column element. Quantity divided by the key column element. So in this case, 4 divided by 1 over 3. 4 divided by 1 over 3. Similarly, you can calculate for the other. It is 16 divided by 2 over 3. Now, in these two, you have to see which is the least non-negative number. The least non-negative number is 12. So this will be identified as the key row. So you have to put this in one box. You have to identify this in one box. So this is the key row and this is the key column. And also you have to identify the one which is the intersection of these two, the column and the row. This is the intersection. So this you must call it as the pivot element. As I told you, for the key row, there is no fixed ratio is not applicable. Whereas for the non-key row, it is the key column element divided by the pivot element, which is 1 over 3. I repeat, 2 over 3 divided by 1 over 3, you get the ratio, fixed ratio as 2. Now, which variable comes in? Which variable comes in is the key column variable. Key column variable is x2. So x2 you should produce. So this will enter the table. And which variable should go out? When you prepare the next table, that is the third simplex table, now x3 should be replaced by x2. So when I prepare the third table, please remember we should not alter the order. The order should remain the same. So x3 should go out and in its place x2 should come in. Remember, the order is very important. You cannot write x1 and x2. You cannot write because x3 is going out. So in place of x3, you have to write x2. Now again, same as what you did in the previous table, second table, profit you have to see from the objective function. X2 profit is 18, x1 profit is 22. Then we have to first fill in the key row elements. So previously in the previous table, you know what is the key row element. Key row element is 4. So this should be divided by the pivot element. Pivot element is 1 over 3. So when you divide by 1 over 3, it will become reciprocal. So in other words, it will become, otherwise I can write into 3. Because it's 1 over 3, division will become multiplication. So it will become 3 over 1. So 4 into 3 will be the value. Similarly, with the other variables, you have to calculate. So it will be 0 divided by 1 by 3, then 1 by 3 divided by 1 by 3, 1 divided by 1 by 3, and this divided by 1 by 3. You get these values. For the non-key row, what should you do? You know, you have learned it in the second simplex table. What do? You take the existing value minus open the bracket. It is the key row element. It is the key row element into the fixed ratio, that is 2. So how did I get this value? How did I get this value? It is 16 minus 4 into 2. 16 minus 4 into 2. And this you have to do it for all. So I have to do this for all the other variables. So how do I do this? Second one, it will be 1 minus 0 into 2 and so on. Z values, I told you there is no change because these are the values from the objective function. And then I have to do the calculate C. How do I calculate C? It is profit into this. So 18 into 0 plus 22 into 1. So 0 into 18 plus 1 into 22. So this is the computed value. And then I find out what is NER, that is Z minus C. I'll calculate what is NER. Now what I find is NER, I don't have any positive number. I have zeros or less than zeros, negative numbers. I don't have any positive numbers. That means I have reached the optimal solution. So since all NER less than or equal to 0, for a maximization objective, this is the optimal simplex table. Hence, X2, you have to produce 12 units. X1, you have to produce 8 units. And when you know that X1 gives you 22 rupees, 22 rupees profit, and X2 gives you 18 rupees profit. So when you substitute the value of X1 as 8 and X2 as 12 in the objective function, you find that the maximum profit is 392. I hope you understood simplex problem. In the next video, we will see maximization problem. Thank you so much.